So now let's proceed to another topic, which is viscosity. So viscosity is the resistance of a fluid to a change in shape or movement of neighboring portions relative to one another. In other words, viscosity refers to resistance of any liquid to flow or move. Or in simple terms, it is the stickiness of liquid. The higher the viscosity is, the more sticky a liquid will be, and this means that the more it resists flow or move. The unit for viscosity is kilograms second per meter. We have here types of viscosity. First is dynamic viscosity. It is the measurement of fluid's internal resistance to flow when force is applied. So to understand it simply, dynamic viscosity is the force needed by a fluid to overcome its own internal molecular friction so that the fluid will flow. Dynamic viscosity measurement is generally applied to non-Newtonian fluids, or those fluids that are sensitive to changes in the amount of force applied on them. They sometimes permanently change their viscosity if a constant force has been applied on them over a period of time. Example for this is the ketchup. As you can observe, ketchup has lower viscosity for us to be able to get it out of the bottle. If it is too viscous or sticky, then it would be hard for us to get it out. But as you can also observe, ketchup is thick enough so it won't flow out when we put it on a burger. Have you tried to squeeze a sachet of ketchup over and over again, applying constant force on it? If you did, you'll know that after squeezing it for a long time, it gets flowy or more watery. Means that its viscosity changes in response to the force you applied. So secondly, we have kinematic viscosity. Kinematic viscosity refers to the ratio of dynamic viscosity to density, or a measurement of the viscosity of a fluid in motion. So kinematic viscosity mostly applied to Newtonian fluids. Those fluids that do not change their viscosity with changes in applied force or shear rate. Examples for this are oil, gasoline, and alcohol. So lastly, we have relative viscosity. This refers to the ratio of the viscosity of a solution to the viscosity of the solvent used. So relative viscosity is important to non-Newtonian fluids. It is the relative viscosity between solution and solvents. Relative viscosity primarily refers to the relationship between molar mass and viscosity. Higher molar mass means higher viscosity. So molar mass is equal to the mass of chemical divided by the total amount of it. So we have here another topic, which is surface tension. Surface tension is the tensile force acting on the surface of a liquid in contact with gas such as air, or on the surface between two immiscible liquids. So surface tension is the reason why lighter objects like needle, powdered black pepper, and leaves float on the surface of water. It is also the reason why droplets of water are in spherical shape. Surface tension is the force exerted by molecules of fluids such as water against objects setting on them. This happens because of the cohesive force that attract molecules of water together. The molecules on the surface being held downward by the molecules below them creates a stable sheet that acts as blanket to those leaves to float. However, If you push the lift downward beneath the water surface, you will observe that the lift submerges. Bisan gaan pa siya. This is because as you push the lift, you are also breaking the surface tension or the cohesive force that hold molecules of the water together. Now, before we proceed to another topic, let's first know this person. This is Archimedes, who is considered to be the father of fluid statics due to be the first one who made research on the field. He was born at 287 BC, and in his birthplace, he spent most of his life. He was the son of the astronomer Phaedius, who calculated the ratio of diameters of the moon and the sun. So, the next topic is buoyancy. Buoyancy is what we perceive as the tendency of an object to raise when it's submerged in a fluid. It can be defined as the ability of an object to float in a fluid, whether it is liquid or air. So in other words, the ability of fluid to make a given object float in fluid. So in here, according to Archimedes, buoyancy is an ability of an object to float. Another also, buoyancy is the principle that explains why some object floats. And also, it is the buoyancy of an object is directly associated to the buoyant force acted on them. To further understand, let's proceed to the next slide. So what we have here is upthrust. I will not read it, so let's explain it directly. So upthrust is most commonly known as the buoyant force. It is the upward force exerted by a fluid to oppose the weight of a partially or fully immersed objects. If an object weight is less than the buoyant force acting on it, then the object floats. However, if the object's weight is greater than the buoyancy force acting on it, then the object sinks. You may wonder and think how surface tension and buoyancy differ. Well, surface tension is the tension on the surface of liquid that keeps light object from falling into the water, while buoyancy is an upward force that pushes objects up. Both of them are working together to keep object afloat. Well, we can say that buoyancy is much stronger and dependable force than surface tension, since surface tension can easily break. So moving forward, so what we have here is the principle of buoyancy. So to better understand Archimedes' principle, let's imagine if we put a 3-kilogram miniature of boat on a large tub full of water. You will notice that some of the water inside the tub overflows as the weight of the boat fully laid on it. Then the boat floats as the buoyant force pushes it upward. This happens because, according to Archimedes, the buoyant force is equal to the weight of the fluid the object displaces. Means that the buoyant force required to make the boat float is equal to the weight of water that goes out of the tub as you put it on the top of the water. To make the boat float, buoyant force must equal to the water displaced by it, pushing at the center of mass of the displaced fluid, which is at the part of the boat that touches the water. And that is how the boat floats. So let's cite an example. So find the position of center of buoyancy for a wooden block of width 3.5 meter and depth of 1 meter when it floats horizontally in water. The density of wooden block is 850 kilogram cubic meter and its length is 7 meter. So to find it, let's first use this formula. F sub B is equal to density times the specific gravity times its volume. So, let's multiply the following. 850 times 9.81 as the specific gravity times 7 times 3.5 times 1. If you will multiply this all, you will have the result 204.29 kilonewton. So secondly, you must use this formula, the volume of water displaced. That is equal to the weight of water displaced times the weight of density of water divided by the weight density of water. And if you will use this, you will have the result 20.825 cubic meter. Since the question said you will find the position of center of buoyancy, you will use lastly this formula. H is equal to the volume divided by its area. Following, you should times 3.5 times 7 divided by 20.825. If you will follow this, you will have a result of 0.85 meter. I hope you gain a lot out from this review. Thank you.